Welcome to a deep dive into the world of technical interviews, where most coding questions are not as random as they seem. After hundreds of coding problems, it turns out that nearly 90% of interview questions are built on a handful of core patterns. Today, we'll explore how recognizing these patterns can transform your approach, making interviews less about memorizing endless solutions and more about understanding the underlying frameworks. Let's set the stage for a journey that will help you decode the secrets behind the most common data structures and algorithms questions. Imagine solving hundreds of coding problems and realizing that most interview questions are cleverly disguised variations of just 20-30 patterns. This revelation is mind-blowing and shifts your focus from memorizing solutions to recognizing patterns. Once you see the connections, technical interviews become much more manageable. In this scene, we'll discuss how this insight changes the game for developers everywhere, making preparation smarter and more efficient. Recognition is the key to cracking technical interviews. Instead of getting lost in endless practice, you start to see recurring themes and structures. This approach allows you to tackle new problems with confidence, knowing that you've seen similar challenges before. We'll explore how developing this skill can save time, reduce stress, and boost your chances of success in interviews. Let's introduce the complete DSA framework that has transformed how developers approach data structures and algorithms. This framework organizes the most common patterns into families, making it easier to navigate and master. By understanding the structure of these families, you can quickly identify the right approach for any interview question. We'll break down the framework and show how it simplifies your preparation. DSA framework begins with core pattern families. These include arrays and strings, binary search, linked lists, stacks and queues, trees and BSTs, heaps, dynamic programming, and graphs. Each family represents a group of problems that share similar structures and solutions. By mastering these families, you gain a strong foundation for tackling a wide range of interview questions. Arrays and strings are the foundation of many coding problems. They involve operations like searching, sorting, and manipulating sequences of data. Interview questions often test your ability to efficiently handle these structures, whether it's finding duplicates, reversing elements, or optimizing performance. Mastering arrays and strings prepares you for a significant portion of technical interviews. Binary search is a classic algorithm used to efficiently find elements in sorted data. It's a powerful technique that reduces search time from linear to logarithmic. Interview questions often require you to implement binary search or adapt it to solve variations, such as finding boundaries or handling rotated arrays. Understanding binary search is essential for tackling many algorithmic challenges. Linked lists are a fundamental data structure that enables flexible data storage and manipulation. Interview questions often focus on reversing lists, detecting cycles, and merging nodes. By mastering linked lists, you gain the ability to solve problems that require dynamic memory management and efficient traversal. Stacks and queues are essential for managing ordered data and supporting operations like undo, redo, and breadth-first traversal. Interview questions often involve implementing these structures, handling parentheses, or processing tasks in order. Understanding stacks and queues helps you solve problems related to order and sequence management. Trees and binary search trees, BSTs, are hierarchical structures used for organizing data. Interview questions often focus on traversals, balancing, and searching within trees. Mastering these concepts enables you to efficiently solve problems involving hierarchical relationships and recursive algorithms. Heaps and priority queues are specialized structures for managing prioritized data. Interview questions often require you to implement heaps, find the kth largest element, or optimize scheduling. Understanding these structures is crucial for solving problems that involve dynamic ordering and efficient access to extreme values. Dynamic programming, DP, is a powerful technique for solving complex problems by breaking them down into simpler subproblems. Interview questions often involve optimizing solutions, handling overlapping subproblems, and using memoization. Mastering DP allows you to tackle challenges like the knapsack problem, longest subsequence, and more. Graphs represent relationships between entities and are used in problems involving connectivity, traversal, and shortest paths. Interview questions often require you to implement graph algorithms, detect cycles, and find connected components. Understanding graphs is essential for solving network-related and relationship-based challenges. Beyond core families, the DSA framework includes pattern skills such as basic dynamic programming, optimal substructure, interval problems, knapsack DP, prefix awareness, probability, and connected components. These skills are essential for adapting solutions to specific problem types and optimizing your approach. Basic dynamic programming involves solving problems by storing intermediate results and reusing them. Interview questions often test your ability to identify overlapping subproblems and implement efficient solutions. By mastering basic DP, you can handle a wide range of optimization challenges. Optimal substructure is a property where the optimal solution to a problem can be constructed from optimal solutions to its subproblems. Interview questions often require you to recognize this property and build recursive or iterative solutions. Understanding optimal substructure is key to mastering dynamic programming and related algorithms. Interval problems involve managing ranges or segments of data, such as scheduling, merging intervals, or finding overlaps. Interview questions often test your ability to efficiently handle and process intervals. Mastering interval problems prepares you for challenges related to time management, resource allocation, and more. Knapsack DP is a classic optimization problem where you select items with maximum value under a weight constraint. Interview questions often require you to implement variations of the knapsack algorithm, handle multiple constraints, and optimize resource allocation. Understanding knapsack DP is crucial for solving resource-based challenges. Prefix awareness involves understanding how prefixes of data can be used to optimize solutions, such as prefix sums or prefix products. Interview questions often test your ability to leverage prefixes for efficient computation. Mastering prefix awareness helps you solve problems related to cumulative data and fast queries. Probability and randomness are important for solving problems that involve uncertainty or random selection. Interview questions may require you to calculate probabilities, simulate random events, or optimize outcomes under uncertainty. Understanding probability helps you tackle challenges in gaming, simulations, and randomized algorithms. Connected components are a concept in graph theory where groups of nodes are connected to each other. Interview questions often require you to find connected components, detect cycles, or analyze network structure. Mastering this concept is essential for solving problems related to connectivity and relationships. Adapting patterns to new problems is a crucial skill. Interview questions often present familiar structures in unfamiliar ways, requiring you to modify and extend known solutions. By practicing pattern adaptation, you become more flexible and creative in your approach, increasing your chances of success. Effective practice involves focusing on core patterns and building your skills through targeted exercises. Instead of solving random problems, concentrate on mastering each pattern family and skill. This strategy helps you build confidence and ensures you're prepared for the most common interview questions. Let's look at a typical arrays strings interview question, finding the longest substring without repeating characters. This problem tests your ability to manage sequences and optimize performance. By recognizing the pattern, you can apply sliding window techniques and solve the problem efficiently. Common binary search interview question is finding the minimum in a rotated sorted array. This problem requires you to adapt binary search to handle rotation and boundaries. By understanding the pattern, you can implement an efficient solution and impress interviewers with your skills. Consider a linked list interview question, detecting a cycle in a linked list. This problem tests your understanding of pointers and traversal. By recognizing the pattern, you can use techniques like Floyd's cycle detection algorithm to solve the problem efficiently. Typical stack queue interview question is validating parentheses in an expression. This problem tests your ability to manage order and sequence. By recognizing the pattern, you can use a stack to efficiently check for balanced parentheses and solve the problem. Common tree BST interview question is finding the lowest common ancestor in a binary tree. This problem tests your understanding of hierarchical relationships and recursive algorithms. By recognizing the pattern, you can implement a solution that efficiently finds the ancestor. Typical heap interview question is finding the kth largest element in an array. This problem tests your ability to manage prioritized data and optimize access. By recognizing the pattern, you can use a heap to efficiently solve the problem. Classic dynamic programming interview question is finding the longest increasing subsequence in an array. This problem tests your ability to optimize solutions and handle overlapping subproblems. By recognizing the pattern, you can implement a DP solution that efficiently finds the subsequence. Common graph interview question is finding the shortest path between nodes. This problem tests your understanding of graph traversal and connectivity. By recognizing the pattern, you can use algorithms like Dijkstra's or BFS to efficiently solve the problem. An interval problem interview question is merging overlapping intervals. This problem tests your ability to manage ranges and optimize solutions. By recognizing the pattern, you can implement an efficient algorithm to merge intervals and handle overlaps. Knapsack DP interview question is maximizing value with weight constraints. This problem tests your ability to optimize resource allocation and handle multiple constraints. By recognizing the pattern, you can implement a DP solution that efficiently selects items. Prefix awareness interview question is calculating prefix sums for fast queries. This problem tests your ability to optimize computation and handle cumulative data. By recognizing the pattern, you can implement prefix sum techniques for efficient solutions. Probability interview question is simulating random events and calculating outcomes. This problem tests your understanding of uncertainty and random selection. By recognizing the pattern, you can implement simulations and optimize outcomes. Connected components interview question is finding groups of connected nodes in a graph. This problem tests your ability to analyze network structure and detect relationships. By recognizing the pattern, you can implement algorithms to efficiently find connected components. Mastering DSA patterns offers significant benefits. You become more confident, efficient, and adaptable in interviews. Instead of feeling overwhelmed by endless questions, you approach each problem with a clear strategy. Pattern mastery is the foundation for technical interview success. Effective interview preparation involves focusing on core patterns, practicing targeted exercises, and building your skills through repetition. By concentrating on the most common patterns, you ensure that you're ready for the majority of interview questions. Preparation is about quality, not quantity. Pattern recognition is not just a theory, it's a practical skill that you can apply in every interview. By identifying familiar structures and adapting known solutions, you solve problems faster and more efficiently. This approach helps you stand out and impress interviewers. Let's recap the complete DSA framework: core pattern families, essential skills, and practical examples. By mastering these elements, you build a strong foundation for technical interviews. The framework simplifies your preparation and guides you towards success. Pattern-based approach to interview preparation is the most effective strategy. Instead of memorizing solutions, focus on understanding and adapting patterns. This mindset helps you tackle new problems with confidence and creativity. Continuous improvement is key to mastering DSA patterns. Practice regularly, review your solutions, and seek feedback. By consistently refining your skills, you become more proficient and ready for any interview challenge. Developing a pattern recognition mindset transforms your approach to technical interviews. You become more analytical, strategic, and resourceful. This mindset is the foundation for long-term success in coding and problem-solving. Applying the DSA framework in interviews helps you quickly identify the right approach for each question. By leveraging your knowledge of patterns and skills, you solve problems efficiently and impress interviewers with your expertise. Conclusion: mastering DSA patterns is the key to cracking 90% of interview questions. By focusing on core families, essential skills, and practical examples, you build a strong foundation for technical interviews. Remember, preparation is about understanding patterns, not memorizing solutions. Approach each interview with confidence, adaptability, and a pattern recognition mindset.